Hello, my name is Isabella O'Brien, and I am a grade 10 student at Westmount Secondary School in Hamilton, Ontario, Canada. Ever since I was a little girl, I have spent my summers up at the cottage, which is located on a saltwater lake on the Canadian Shield region in the northern part of Ontario. Over the years, I have noticed changes in our lake, from the decline of the number of clams in our lake to the thinning of their shells, as well as crayfish disappearing completely. Other similar lakes in the region have seen an invasion of jelly-coated water fleas, as well as an increase in toxic algae blooms. I learned that one of the contributing factors to all of these events was something called lake calcium decline. This discovery is what led to my experiment. Lake calcium decline is an emerging environmental issue that is affecting saltwater shield lakes in Canada, the United States, and Scandinavia. This problem is a legacy of acid rain. The human-produced sulfur dioxide and nitrogen oxides released into the atmosphere form sulfuric and nitric acids, which were then deposited in our lakes and soils in the form of acid rain. The acidity caused pH levels to decrease, which in turn caused rapid leaching of lake and soil calcium. Although lake pH levels have stabilized due to air emission control policies, lake calcium levels are continuing to decline and are approaching ecologically critical levels. The declining calcium has put Daphnia pulex at risk, as it has been discovered that they are unable to reproduce at calcium levels below 1.5 milligrams per liter. Daphnia pulex are a keystone indicator of many aquatic food webs and are principal grazers of algae. Their decline has implications for the entire lake ecosystem. One excellent source of calcium are waste shells. Waste shells are a readily available and abundant reusable resource, and they are 95 to 98% calcium carbonate. Each year, millions of metric tons of shell waste is produced worldwide, the disposal of which has become a global issue. Inspired by my previous work on mitigating ocean acidification by using the pulverized recycled shell waste, I wanted to test the same technique as a chemical solution to lake calcium deficiency. To do this, I set up two trials. Trial 1 tested low calcium level lake water, and Trial 2 tested critical calcium level lake water. Each trial had a control and two treatments. The control was lake water with no shell powder added. Treatment 1 had 10 milligrams of shell powder added, and Treatment 2 had 50 milligrams of shell powder added. They all had 10 replicates or test cups each, and each one was populated with one juvenile Daphnia less than 24 hours old. The trials were run for 21 days. The lake water calcium level in Daphnia survivorship, the number of broods, and the number of offspring produced increased in all treatments with the shell powder added, and increased significantly in Trial 2 with the critical calcium level lake water. My results clearly show that the addition of shell powder to increase calcium levels can be effective for both the remediation of critical level calcium lakes as well as the preventative measure in low-level calcium lakes. This method has the potential to be beneficial in maintaining Daphnia pulex populations. This will protect lake biodiversity and help mitigate algae blooms, while at the same time helping with the worldwide problem of shell waste disposal. Thank you so much for listening, and I look forward to receiving your comments and questions.